Welcome to another episode of Java 2D Game Engine Development. We are going to do episode 4. Last episode, we worked on adding debug features to our game engine. This episode, we're going to work on adding crash error reporting and also other exception handling. Back to reiterate what we're going to handle this part. Last episode, we acknowledged the problem with our isRunning statement. We're going to return whether a game is running or not, but if we were to run into a game error or a game crash, at no point would running ever be set to false, would be correct if the game did crash and indeed is not running, but we wouldn't have called the shutdown method in order to go ahead and tell it that the game is no longer running. So what we need to do is go ahead and tell the game that it stopped. So in order to do that, we're going to have to make sure we catch those exceptions in our code. So first thing we're going to do is go ahead and just throw an exception real quick. So we're going to go ahead and comment out this print line statement real quick. And let's make sure our debug mode is enabled. And we're going to come down here, we're going to write some code. And we're going to write something that's going to make sure we get a runtime exception in our game. So go ahead and just do a divide by 0 error. We're going to go ahead and run our game. So if we go ahead and run our game here, we're going to realize that indeed that the game did throw an exception and our game stopped. And so we don't really have a way to test right now if a game is running or not to see that value, but I can promise you and guarantee that it in fact still says it is running, because we never set it equal to anything else. So in order to fix that, let's go back up to our game loop. So we're going to fix some code first. So what we're going to do, we're going to add a try catch here real quick. And we're going to put our code inside this. So now, when we try to run our game thread, we want it to catch any runtime exceptions. That way, our game engine can handle those different scenarios and we can know what to do and how to handle it. So we're going to go ahead and say runtime exception. So that way we can catch any runtime exceptions. And that way we can handle them. So our game will attempt to initialize our engine and also then run the game thread and process our game. And at any point we catch any exception during these two steps and it's not caught explicitly in code, our game engine will handle it as a crash report. So we'll go ahead and we'll make a new method real quick and we'll go ahead and call it crash alert and we'll pass in this exception so we can handle it really while you're on in our game. And so if we come down here to the end our game called class, we're going to create a new method. Instead of making this private, we're actually going to make this one protected instead of doing private like we did for everything else in our methods. The purpose of making this method protected is because we want to have the engine do some basic error handling for us in case we crash. We want some guidelines and just some basic functionality to happen when our game engine crashes. We also want our game to determine if it wants to have some special stuff happen if the game crashes. So we make this method protected. We can have our game class, since it is extending our engine, our game can have its own unique form of handling each crash as it happens, which is exactly what we want to have the ability to do. So let's go ahead and add the parameter real quick, runtime exception. And for now, all we're going to do in here is going to be the basic Java error handling. So we're just going to go ahead and do a stack trace. And we're going to go ahead and print that so that way we can tell what threw the error, we can track it back down, and we can find what caused it. So now, if we were to go ahead and run our game, you would see it looks the same because overall we have not changed the way the game executed at all. We go back up to a run method. It tried to keep running our thread. It failed. We came out of our game thread, threaded method call, and the game is ended. But we still never set running equal to false. So at that point, the easiest way to do this is once we finish doing all the logic in our try catch, we go ahead and add a finally clause. And so finally, what it says. Once we get done trying to do everything inside our loop, whether we had a successful call or whether we caught an exception and we handled it, we want this code to run after this try is done. So we'll go ahead now, and this is where we'll set running equal to false. that will signify that our game stopped running. So whether our game has naturally shut down because of the shutdown method, it will exit and leave this thread loop, come in the finally clause, and set our game state to false so we're no longer running. Or if instead we try to run our game thread, when our game crashed, we'll handle that crash and then we'll go ahead and shut down the game and warn that the game in fact is running to false. That should be all we really need to do from here. If we go ahead and test that, well, first, actually, let's go ahead and just show you how we would, in fact, go ahead and add custom error handling to our game. So all we would do is we would override that method from our parent class. So that override would just signify that we're overriding the method, and we could easily just go ahead and call this parent class. You can just pass in, so you can do whatever the base features are for handling crash report. Then we could also, so we could handle all the basic engine defined crash alert handling. Then we can also define some custom stuff. So we can do things like write to a log file. So if we had our game running in a real production environment, so say someone downloaded your game and trying to run it, if the game crashed, likely we'd like to save a log somewhere, so that way a user could go back and they could see what happened, or they could end up sending an error report to your company if you had a company, and they could look at the log and they could go and do bug fixes and stuff like that. You could also just send an error email. You could say if the game crashed in the middle of doing something, maybe we didn't get a chance to save, so you can check to see when the last time the game was saved. You can do stuff like that. So things like different Windows programs will do this. So if you do crash for any reason, they got temporary files, we'll store those files in there. So that way you come in, open the program back up, you still have your files in the recovery mode. So you can do kind of the same thing almost here. So you can go ahead and you can do write to save files, or we can do anything. But for now, we're not going to really need this step. Actually, let's use this step because we'll just explain how this additional crash alert can help. So what we're going to do is we're going to create a new package real quick. And we're going to call this package exceptions. And what this exceptions class is going to do is it's basically going to give us we're going to find a new exception for us real quick. And we're going to call this an engine exception. So this engine exception is going to go ahead and extend a runtime exception. The reason why we want to define our own exception, we want to define our own exception for our engine, because maybe sometimes when our engine fails, if it is an engine specific problem, maybe we want it to handle that exception differently as compared to being a null reference error or something else like that. So defining our own engine exception does two things. It allows us to signify the difference between any other random Java error that could happen or specific engine failure, that we can handle this two differently, but it also specifies when it was a result, the problem was a result of our engine not being able to do what it needed to, or if it was indeed just a code error. So let's go ahead and just create a default, a basic constructor, and we'll just call this the engine exception. And then we'll just do the overwrite the basic string message version of our runtime exception. And so we'll go ahead and supercall that, and we'll just bring in the message. And we'll actually customize this message we did. So we'll just, for now, all we'll do with engine. So all we'll do is we'll just append the words engine crash to our message, just to make it a little bit more clear that in fact our engine did fail and had nothing to do with anything else. So let's finish that up here, and let's just go back to our game. So now since we have this custom crash alert, we can now instead, let's not call our parent at all. We'll just ignore that and we'll define our own error handling. So instead, if we get a runtime exception, we want to check if this is, an engine exception. So what we can do is we can create a new exception, and we'll make this an engine exception. And then we'll pass in our exception and get the message. Or we could really just change it into engine exception will then take a parameter of an engine and can do any amount of things. But we'll just do this for now. And we need to go ahead and import that class real quick. So we'll go ahead and Control Shift N, and we'll import our engine exception. Is we'll print the stack trace of this exception instead. So we go ahead and run our game now. We'll see we'll have a slightly different exception. And this one will denote that it is an engine exception. And we'll say our engine crashed because we divided by 0. And then that's exactly what we want to happen right now. This shows that this was an engine problem, not necessarily a code problem. So this means that our engine was trying to do something it normally should be able to do, but it failed. And it failed because it tried to divide by 0. And it's because our game launched and it failed at this place specifically inside of our engine. Technically, what we would normally do is we check this runtime exception, and you could check the class type and see which class it extension from. You can handle it differently, but just for the sake of showing you how to create a new exception for our engine and what we can move forward, it kind of explains what it can be used for. So that really kind of wraps up what we should be doing for our engine. That's everything we need to get the game thread set up. Next episode, we're going to focus on setting up our game window, and from there we can really dive in and actually start programming our game to really do things. So until next episode.